Hello, my name is Ray Marquis. I'm a senior application engineer at Valin Corporation, and this video is going to cover the simple setup and use of some IO-Link sensors with Omron's IO-Link master connected to an Ethercat bus coupler and then up to an NX series Omron PLC. There are two ways to do the configuration for the IO-Link, and in order to do that, you need to have your configuration. It's a good idea to kind of sketch it out maybe, or I'll show you later that the mappings for your sensors and devices come with the devices themselves or are available online. In this case, I'm going to have an E3Z sensor from Omron, an E3AS sensor from Omron, and then a DW sensor from Contronex. We won't go too much into the Contronex in this video, but we will do in another video where I show how to add third-party devices to an Omron PLC IO-Link master. For the E3Z sensor, we've got PDO mapping. This is the data that's exchanged over Ethercat with the PLC, and that information comes from the IO-Link master. So in the 2 bytes that are available for the E3Z, we get the monitor output data, and that is the incident light level, and then the bit data, which will give us the actual output saying whether the light levels are above or below the threshold we set. It gives us some stability info, warnings, etc. The E3AS uses a bit more info. In byte 0, byte 0 and byte 1, we have the monitor output data. That's the light incident level. We have a received light monitor, and then in the 4th byte, byte number 3, is the bit data. So it's a good idea to know this stuff. If you get an Omron sensor, in the box with the sensor is the mapping data so here's the data from the sheet for the E3Z sensor, and you can see here's byte 0 referenced. Says it's the monitor output and then what the data is. And then here's byte 1 that shows the function or assignment of each bit and then what that bit value means. So if we keep this sheet handy and then want to do this manually, we would have to go through a few steps. After we've configured our Ethercat network, in this case, my IO-Link master unit is on a bus coupler connected to the PLC. You'll see that all in a minute, but I've got the bus coupler selected here. I'd have to go in and do the PDO mapping to match up with the device that I have using that sheet that we saw here. Then I'd have to go into the unit operation settings in Sysmac Studio and enter some values in here, the device ID, vendor ID, and so on, which is on that sheet. And then finally, I'd have to go in and make sure that I map my IO variables correctly here. And you can see, for instance, if I have this sensor on here and we saw that there were 2 bytes for that sensor, it really just says, oh, there's this port 1 input data 0 and port 1 input data 1, and they're each a byte. And what they mean isn't really obvious by this IO map. The second method is to do this auto configure. And the way that you would do that is going to be shown in this video. The auto configure of the IO-Link master starts when you've created your project in Sysmac Studio and you've already configured the Ethercat network following the directions that we've got in other places on the internet and on our website. In my case, I have a PLC with an Ethercat coupler. So you can see here, I'm online with the PLC, and then I'll go here and select Edit Slave Terminal Configuration. I did that by right-clicking on the Ethercat coupler highlighted in blue there. Once I'm here, each module, each unit that's connected to the coupler is highlighted here. If I go to the last one and click on it, this is the NX ILM 400. That's the IO-Link master unit. And you can see there's some PDO mapping here. If I double click on it, that'll take me to the unit operation settings. You can see they're all zeros or default settings here, process data length. Everything is just like that. If I go back to the IO map and look at the unit, I can scroll down to the NX ILM 400 and then go to port 1. And you can see some data changing here, changing values. If I move that sensor around, you can see it changing. So just by connecting the sensors to the IO-Link unit and then powering up the system and creating the Ethercat network, then the sensor is actually there, it's connected and it's working. And there's some stuff going on in this byte 2 that we saw. You can see that changing. It's not very straightforward as to what this data is. So the next step is to go back and close these windows out. I'm going to click on the IO-Link unit here. That's the NX ILM 400. Next, I'll right click on it and select IO-Link Master Simple Settings. Which brings us to this window. Next, I right click in this area up here where the devices should be listed, and I'll select Compare and Get Actual IO-Link Information. And you can see that the actual devices are listed on the right, but there are no devices listed on the left. In order to get the configuration in the PLC to match the actual configuration that's connected, I just click on this button that says Get the Actual IO-Link Device Information. The first two items in the list are Omron items. The last one is a Contronex sensor. I will have another video that shows how to add a third-party device to an Omron PLC. Once that's matched, I'll say OK by clicking on OK. And it shows that these devices came over here. It gives information about each device if I click on it. Once this is matched, you want to make sure that to select Generate Process Data Structure of the IO-Link device down here in the IO map box, and then click on OK. A message will come up that just says it's going to change the settings that are there. That window closes, and now you're back at where you started with the NX ILM 400 highlighted. When I double click on the IO-Link master unit now and go to the operation settings, you can see that information has been filled in for each of the connected devices. There's the device ID that wasn't there before, the vendor ID, the revision number, the number of bytes in the process data, and that's all been automatically filled in now for the devices that were connected. In addition to that, if we go to the IO map and once again drill into the NX ILM unit that's connected to the Ethercat coupler, if I look at port 1 input data, you can see that instead of just having 2 bytes here that don't really have any clarification or clarity to them, each bit now in that byte, it has a usable or a meaningful description to it here. If we go offline, I can go in and create variables for each one of these data points that come through on the PDO mapping. There's port 2 input data. I'll move this over just a little bit so we can see. It's an array of 2 bytes, but when you look at it, it tells you more clearly what those bytes mean. And then here's another set, another 2 bytes for that same sensor. I can go in and create these variables here however I like. I can have it auto create them, or I can type in names for these variables, and then I'll be able to use them in my program so that I can watch for the output of that sensor or the monitor level or these warnings, etc. In subsequent videos, we'll talk about how you can get the settings that you've got for each one of these sensors saved so that when you swap out a sensor, it'll automatically put those settings down to the sensor without you having to do it manually. I hope you found this helpful. If you have questions, you can reach us using the information on the screen.